We'll solve question number 39 of test series 1. This is a strength of material question. There is a cantilever beam loaded by a uniformly distributed force of W per unit length. At the free end, it has a spring of spring constant K. The ends are B and A. Now, before the load is applied, there was no deflection in the spring, and we have to figure out the spring reaction after the force has been applied. So in this case, we have to get the deflection of point A from beam deflection and from spring deflection, which will be equal to each other. So from beam deflection, we have to get the deflection of point A because of the distributed load of W, as well as because of the reaction from the spring. Let's assume that the reaction from the spring is F, and the length of the beam is L, and the area moment of inertia is I, and the Young's modulus of the beam material is E. Now, for the distributed load, the deflection will be equal to delta W, which is W L to the power of 4 upon 8 EI. And because of the force, concentrated force F, the deflection will be FL cube upon 3 EI. The difference of these two is the net deflection of point A downward, which is nothing but F upon K, because that will be the deflection of the spring also. So if we substitute the value of delta F, delta W and delta F from these equations, we get WL to the power 4 upon 8 EI minus FL cube upon 3 EI equal to F upon K. So we rearrange this equation to get WL to the power 4 upon 8 EI is equal to F 1 upon K plus L cube upon 3 EI. Hence, F is equal to WL to the power 4 upon 8 EI divided by 1 by K plus L cube upon 3 EI. Now, this expression can be further simplified like this. So we can say it is WL to the power 4 divided by 8 EI 3 EI upon L cube K plus 1 into L cube by 3 EI. So this EI and this EI gets cancelled. This 3 goes to the top, and this L cube cancels out the L to the power 4. So this gives us 3WL upon 8 1 plus 3 EI upon L cube K, or 3 by 8 WL upon 1 plus 3 EI upon L cube K, which is option C.